Okay, so the idea in factoring by grouping is you would normally have 4 terms when factoring by grouping. So in this case, part A, we have y cubed minus y squared plus 3y minus 3. And you often group in groups of 2 terms. And if we're being nice, you're going to group the first 2 terms together and the second 2 terms together and factor out the GCF. Does that sound familiar? Okay, so in other words, I want to group the first 2 terms together, y cubed minus y squared, and factor out the GCF. So what would the GCF of y cubed and y squared be? Y squared, and then you pull that out, and then what's left from the first 2 terms if you factor out a y squared? Good. Does everybody see that there has to be that 1 there? Does everybody see that? So it's really, in the original polynomial, you can think of it as y cubed minus y squared times 1. And when you factor out the y squared, that 1 stays. And so you get y minus 1 in the parentheses. Now do the same thing with the second grouping. Now the idea is that you want to get the same thing in parentheses as you had in the first grouping if possible. That's when factoring by grouping is going to work. So what could you factor out of the second group? What's in the form of a GCF, positive or negative, so that you get the same thing, y minus 1 in parentheses? 3, and don't forget the operation. It's still plus right there, right? So you're going to factor out a plus 3, and then what's left? 3. You're factoring out a plus 3 from 3y minus 3. Think of it as minus 3 times 1, so what's left? Well, no, what's left? When you factor out the 3, what's left? Y minus 1. Now, does everybody see now this looks a lot like the last problem? Yes. Okay. So then we've created 2 terms in this polynomial, 2 products. What's the GCF of those 2 products? The quantity y minus 1 is in both of these terms. And so the idea is to factor that out. Use the distribution property to factor out the y minus 1. But then what's left if you do that? The y squared from the first term and the 3 from the second term. And so you get the quantity y squared plus 3 times the quantity y minus 1. Notice you do see pluses and minuses in it, right? But it's inside the parentheses. If you look at it big picture-wise, you've got 2 quantities multiplied together. So you know you're finished factoring this thing, hopefully. I mean, sometimes those individual quantities factor further, but not right now. So the strategy is to group groups of 2, factor out the GCF out of the groups of 2, and then what's remaining in the parentheses, if the method is going to work, is y minus 1. Or I'm sorry, the same quantity. In this case, it was y minus 1. Part B, we're factoring by grouping. T cubed plus 6t squared minus 2t minus 12. So what's the GCF of the first 2 terms? Well, we're hoping we can group the first 2 together, right? Hopefully we don't have to rearrange it. Sometimes you do, though. Not in this case, I don't think. What's the GCF of t cubed plus 6t squared? T squared. What's left on the inside when you factor out t squared from just the first 2 terms? T plus 6. Now, what's the strategy? You guys tell me. On the next grouping, minus 2t minus 12, what's the strategy? Yeah, because what does that leave us with inside the parentheses if we take out the negative GCF? Positive t plus 6, yeah. We get the same thing in parentheses, in other words. So the idea is we've got to factor out a minus GCF of minus 2. And then you guys take a look at this, make sure you believe that. You factor out a minus 2 from minus 2t, what are you left with? So just t, right? You factor out a minus 2 from, you undistribute a minus 2 from a minus 12, what's left? Plus 6. Everybody see how that works? Now you know it's going to work, but you're not done. It's not factored, right? Because of that minus in between the 2 terms. So what do you pull out? You factor out the common factor of t plus 6, right? Quantity t plus 6. And what's left from both terms? T squared minus 2. That's it. Doesn't it seem easier than the first time you learned it? It's not necessarily because I'm better than your last teacher. It's just your brain gets used to it. Okay, we have in part C, a cubed minus 3a squared plus 6 minus 2a. Get me started. What am I going to take out of the first two terms? A squared. A squared. So I'll take it a squared out, and what's left from just the first two terms? A minus 3. Now don't call out your answer. I want you to think about this now. The second grouping would be the plus 6 minus 2a, wouldn't it? So don't call out an answer. I want everybody to have a chance to think about it. What could you factor something out of that to get a minus 3 left in parentheses? Don't call out the answer. Think about it. Think about it. Okay, now that you've had a chance to think about it, what could you factor out?
-2.
Everybody agree? -2. Now, you factor out, let me leave some space here so I can show some scratch work. If you factor out a -2 here and you don't change the order, what's left? So you get a -3, right? Plus a, because you factored out the -2. Right? But how do we want to reorder it? -3 plus a is the same as what? So, well, no, I mean, I'm good with the -2. That's good. But the thing is, we've got inside the parentheses here, we've got a minus 3. In here, we've got -3 plus a. But isn't that the same as a minus 3? A plus a -3 is the same as a minus 3. You can turn it around, in other words, make it a plus -3, which is the same as a minus 3. Does everybody see that? All right. All right, so then what's the common factor between the two products that you just created? What can you pull out? You can pull out the a minus 3, right? I'm pulling it out on the right side. You can pull it out on the left side if you want, if you're more comfortable with that. What's left inside the parentheses if you do that? What's left over from both terms, in other words? What's left from this guy? A squared. What's left from this guy? -2. There you go. Does that make sense to you? Now, if you foiled that out, you would, believe it or not, you'd get the same thing you started with. Does everybody realize that? That's probably a good thing to talk about. So let's show this is, we go the other direction, it's multiplication. Multiply this out. So here's your check. If you multiply the first terms together, a squared times a, what do you get? A cubed. If you multiply the outer terms together, including the operation, what do you get? Minus 3a squared. You multiply the inner terms together, what do you get? Minus 2a, and the last terms? Plus 6. Is that equivalent to what we started with? A cubed minus 3a squared. Okay, we've got the minus 2a before the plus 6, but it's the same. Well, it's not the same thing, but it is equivalent, right? Yeah. Okay, so that's your check. You know you did it right.